So substitution reaction of alkanes, it will continue until all of the hydrogen present in the hydrocarbon no, every time we are supplying a new molecule of a chlorine, so it's like every time chlorine, it is present in excess of a chlorine. Excess of chlorine means more than enough. So example, if you have C3 and H8, you have the first molecule of chlorine, you have excess of chlorine. Excess means more than enough. So every time chlorine, new molecule of a chlorine is available for the reaction to occur. So what will be the product? C3H8 plus Cl2. What will be the product? How many carbon, how many hydrogen, and how many chlorine? This is not octane, it's 3 carbon, so it is propane. Octane number is, the name is according to carbon, not because of hydrogen. So this will be CH. Every time one of the hydrogen replaced by chlorine. Yes, so normally they don't ask the compound name, they normally they ask to complete the equation. So what happened? One chlorine will enter and one hydrogen will replace. So it will form C3H7 Cl plus HCl. Is it clear?
Yes, sir.
Then because we are using excess of chlorine, excess means more than enough. So what happened? This molecule C3H7 Cl react with another chlorine molecule. So what will be the product? What will be the product if so again one chlorine enter, one hydrogen will leave. So the product will be C3H6 Cl2 plus HCl. And this will continue, but in exam they don't say write all the equations. So they don't mention write all the equations. Sometimes they say write 2 different equations for substitution reaction between alkane and halogen. And normally they ask the conditions for this reaction to occur. So it happen in ultraviolet, presence of UV light and high temperature. Most of these halogen alkanes, they are used as refrigerant or gas. Like maybe you have heard this name freon gas. Freon gas is used. Why ultraviolet light? Why we use UV light? Because UV light can break the bond easily. Ultraviolet light means more energy. So this UV light can break, because first the bond should break in chlorine and then the reaction occur. That's why we need ultraviolet light.
Sir, when you did the chain reaction,
Yes.
Why didn't you make it H2Cl? Because I think there was another hydrogen that went in the bottom one.
In this one?
Yes, sir.
So we have 7 hydrogen. Out of 7, one of the hydrogens escape.
6.
So it will become 6 hydrogen atoms.
And sir, but where did the HCl from the previous equation go?
It will escape because this is a gas, so it will escape from the mixture. It's not having further reaction. That's why we did not include there.
Okay, sir, I understand.
So it's like HCl produced in the first equation is not having any contact with the second equation because it is removed or it is released from the mixture. It does not react with any other substance present here. When compounds have same molecular formula, but they have different structures, we call them as isomers. Example, if I draw a compound CH3, CH, CH2, CH2, and CH2. What is the name of this compound? What is the name of this compound?
Butane.
Butane. Name of the compound is butane. So this is butane. And what is the molecular formula of this compound? How many carbon atoms are there?
4H.
And how many hydrogen atoms are there?
4 carbon atoms.
10.
10. And without counting, you can identify
10.
from formula, because the number of hydrogen
Yeah,
should be
4
twice
cubes
plus
are
2.
8.
4 multiply 2 plus 2.
Yeah, so this is butane. If I draw another structure, this is CH3, CH3, CH. This is a branch alkane. So when there's a branch alkane, we select the longest carbon chain. So this is our longest carbon chain. Then we number the carbon atoms. I can number from left to right, 1, 2, 3, or I can number from right to left, 1, 2, 3. So both cases, the number to second position, I have a branch. So second position, I have a branch. So I will say this is 2, because second position we have a branch. How many carbon atoms in the branch? So 1 carbon atom is there in the branch. We call that as meth. And because it is a branch, so we say YL. So it's 2-methyl. And how many carbon atoms in the chain? So 1, 2, and 3. So 3 carbon atoms in the chain. What we call that as propane. So this is 2-methyl propane. First, what we did, I already explained this idea that how to name these hydrocarbon in a branch 1. We select the longest carbon chain. Numbering should start from the nearest branch. The branch contains 1 carbon atom. That's why I say meth. Because there's a branch, so I will say YL. So it's 2-methyl. Prop, because there are 3 carbon in the main chain. And ane, because they have a single bond. So it is 2-methyl propane. But if I write a molecular formula, what is the molecular formula of this compound? How many carbon atoms?
4.
And how many
Butane.
hydrogen atoms?
10.
10. So you can see here, 2 compounds have the same molecular formula. The molecular formula of butane and the molecular formula of 2-methyl propane, they have the same molecular formulas, but what is different for them? Their structures are different. So what we call butane and 2-methyl propane are isomers of each other. So the term isomer means when 2 compounds have the same molecular formula, but their structures are different, then we call them as isomers. Is it clear?
Yes, sir. But sir, in methyl orange, the meth is for the 1 carbon in the branch.
In methyl orange?
No, in methyl propane.
Methyl propane? Meth is, yeah, because it's a 1 carbon in the branch. That's why it's meth. And YL is for branch.
Okay, sir.
Second position, we have a branch. That's why we call 2-methyl, and prop because there are 3 carbon. And throughout the chain, they have a single bond. That's why we call ane. So it's 2-methyl propane. So 2-methyl propane and butane are isomers of each other. So in exam, they don't, this question, normally how you find a question, they say draw isomer of C4 and H10. And sometimes they say state the name of each isomer, but most of the time you'll find a question, draw isomer of C4H10. So to draw the isomer of alkane, what you will do, the simple rule you will follow for alkanes, because you can draw isomer of alkane, you can draw isomer of alkene, alcohols. So first thing, because our main topic is alkane, so if you want to draw the isomer of alkane, so what you will do, first draw the straight chain and then draw the branch. So only first draw the straight chain and then draw the branch one, then it will be considered as a isomers of each other. I'll give another example. First copy this part.
Sir, one small question. Sir, can it be written as propane to methyl?
The standard naming, this is a system which is known as International Unit for Pure and Applied Chemistry. So this is made by the chemist, group of chemists, not one. So they made a like a rule or a system. That's why it should always be propane at the last and 2-methyl at the beginning. The branch first and the main chain at the last. This is according to the system.
Okay, sir.
So if you say propane 2-methyl, according to system, that's considered as wrong. So you will not score marks if the question is name the isomer. IOPIC means it's a system international unit for pure and applied chemistry. This is a system which is used to name these hydrocarbons. So normally in exam, they give you the structure. You don't have to use compass to draw the molecule of Afif. Sometimes they say show all the bonds. Like I'm giving you an example. If they say draw two isomers of C5 and H12, show all the bonds present in the molecule. Now, as we know from the formula, we can identify it's an alkane. And I give you a hint that how to draw isomer of alkane. So best thing, first draw the straight one. One you will draw a straight chain, another one you will draw a branched one. So how to draw a straight chain? First draw the carbon atoms. Don't bother about hydrogen. First draw the carbon atoms. Now I have 5 carbon atoms, so I want to draw a straight chain. So 1, 2, 3, 4, 5. So I draw first, just draw the carbon atoms. Now, as you know, carbon maximum can form 4 bonds because it belongs to group 4. So maximum number of the bonds, it can form 4. So one of the bond is formed here by the carbon. How many hydrogen should be here? The first
3.
carbon, 3. So just make 3 hydrogen. 1, 2, and 3. And why I'm not writing like CH3? Because in the question, what I mentioned, show all the bonds present in a molecule. If this statement is written, show all the bonds, then you have to represent the bond between carbon and hydrogen. You cannot write CH3. Now, the second carbon, already 2 of the bonds are formed. How many hydrogen should be there? Carbon belongs to group 4. It can form maximum 4 bonds. So 2 bonds are already occupied. So remaining will be 2 hydrogen. How many hydrogen will be here?
2.
2. Because 2 of the bonds are already occupied. How many hydrogen will be here?
2.
And then the last one, the right hand side, how many hydrogen?
3.
3, because
3.
1 is occupied, so it will have 3 bonds. 3 hydrogen bond, carbon hydrogen bond. So this is a structure which you draw and you represent all of the bond. Now, what is the name of this compound? This is a straight chain alkane. So we don't, for a straight chain, we don't have to number, we don't have to select the longest chain. We just simply name according to the number of the carbon. What is the prefix used for 5 carbon atoms?
Pent.
So it will be pent because of 5 carbon atom, and because they have a
Part
single
numbers.
bond, so it will be pentane.
Yeah.
Pent is because of 5 carbon and ane because they have a single bond. That is the first isomer, so pentane. C5H12, we draw pentane. Then the second one is a branch. So first, to make a branch of which include 5 carbon atoms of 1, 2, 3, 4. Then I have to make one of them as a branch, but I cannot make a branch with the first or the last one. That's not considered as a branch. The branch should started with the second one. So it will be, either I can put on this one or the other one. So this will be carbon here. I put a branch. Now, how many hydrogen this will have on the left hand side?
3.
So it will have 3 hydrogen. How many hydrogen this will have?
1.
This carbon on the right hand side, second last.
2.
So sir, the main formula is just the branch and the straight.
Yes, to make an isomer, draw one of them as a branch, another one as a straight.
Yeah, that's it. That's the main formula.
So you show all the bonds. Now, how to name this a branch hydrocarbon? You select the longest carbon chain. You don't bother about hydrogen. You check the longest carbon chain. 1, 2, 3, 4. So this is having the 4 carbon atoms. I selected. Then this one is This one is a branch. So I count the number. If I count from right hand side, so 1, 2, 3,
3,
4. So third position, I have a branch. If I count from left hand side, so 1, 2, 3, 4. Which numbering I should follow? Left to right or right to left?
right to
Right to left, the branch is at 3. Left to right, the branch is at 2. I should follow the numbering from left to right. The branch is coming with the second carbon. So this is 2. The second position, we have how many carbon in the branch? How many carbon atoms in the branch? So one carbon atom in a branch. So it's one carbon atom, that's why we call meth. And because it's a branch, so we'll say YL. So it's 2-methyl. And because there are 4 carbon atoms, so we'll say bute. And they have a single bond in. So it is 2-methyl butane. So we can say propane and 2-methyl butane are isomers of each other. Yes, Abdullah. Pentane, okay, yes. Yeah, pentane. Pentane and 2-methyl butane are isomers. How it is 2-methyl? Because when you select the longest carbon chain, there are 4 carbon atoms in the chain. When you count from the right hand side, so 1, 2, 3, 4. So branch is coming with the third carbon. If you count from left hand side, 1, 2, 3, 4, branch is coming with the second carbon. We always follow a numbering where the branch is closer. So on the left hand side, from the left hand side, the branch is closer. That's why we are counting from left to right. Yes, you can make 2 branches even in a question. But because the reason I prefer that you draw only 1 branch. Reason for that, because sometime it can be 2 branches, you can make 2 branches, that's not an issue. But sometimes they say name the isomer. So when you are making more branches, means you are making the name complex. But I can make more branches, like example, first copy this part, I will draw another isomer of this. Yes, I will draw another one. First copy this part. So if you want to, like a student want to draw more branches, you can draw more branches. So example, I have 5 carbon atoms. So 1, 2, 3. But keep in mind, first and the last one, you cannot draw the branch. That's not considered as a branch. Branch is only considered for the carbon in middle, but not in the last. So only carbon I'm left with is a central carbon where I can draw the branches. And I have to arrange 5 carbon atoms So 3, I arrange them in a straight, and 2 of them I made branch, 1 up, 1 down. This will have 3 hydrogen. I'm not showing all the bonds because of space. This will have 3 hydrogen. This will also have 3 hydrogen. And this is also having 3 hydrogen. The central carbon does not have any hydrogen. Why? Because all of the bonds are occupied with carbon. Then we select the longest chain. So if I count 1, 2, 3, maximum 3 carbon atoms are there. So we select the 3 carbon atom as a main chain. Then I count from left to right or right to left. Both cases, the branch is coming with a second carbon. So what I can do, there's a branch, 2 branches are there at the second carbon. So 2, 2. Because there are 2 branches, so both of branches are at second position. That's why I call 2, 2. How many branches are there? There are 2 branches. That's why I call di. So it's 2, 2 di. How many carbon atoms in the branch? 1 carbon atom in a branch. So I will say meth. And because it's a branch, so I will say YL. So 2, 2 dimethyl means there are 2 branches of methyl group and both are at second position. So that's why 2, 2 dimethyl and 3 carbon atoms are there. So we'll say prop and single bond N. So it is 2, 2 dimethyl propane. That is also an isomer. So C5H12, you can draw 3 isomer. You can draw pentane, you can draw 2-methyl butane, or you can draw 2, 2 dimethyl propane. Is it clear? Is it clear this name of this branch hydrocarbon? Because it is having 2 branches, that's why, and the numbers are representing the position of the branches. Because there are 2 branches, that's why I've used the word di. And each branch contain 1 carbon atom, that's why it's methyl. And prop, because there are 3 carbons, so prop, they have a single bond in, so it's 2, 2 dimethyl propane. Now another question. Draw 2 isomers of C6 and H14. So if you want to draw the 2 isomers of C6H14, and in the question it is not mentioned show all the bonds, in that case you can just write CH3 or CH2 instead of writing all the or showing all the bonds of carbon and hydrogen. Because it's an alkane, so for alkane what we draw, to draw an isomer, we draw a straight chain and we draw a branch. So 6 carbon atoms, straight chain. So 1, 2, 3, 4, 5, 6. And then how many hydrogen on the left hand side carbon should have? This will have 3 hydrogen. This will have 2 hydrogen. This will have 2 hydrogen. This will also have 2 hydrogen, 2 hydrogen, and 3 hydrogen atoms. What is the name of this compound? Can you identify the name?
Hexane.
Hexane.
It's hexane
First
because
single bond and 6 carbon.
so it is hexane. Now I want to make a branch. So because to make a branch, don't draw the same number of the carbon, because and in exam, my advice, try to draw minimum branches. Don't try to draw a complicated structure, because reason for that, sometime they say name the hydrocarbon or name the isomer as well. That time you may lose a mark for naming if you draw too many branches or draw a complex hydrocarbon. So just draw, because we have 6 carbons, so I draw first 5 in a straight chain, and then I have to put a branch. I cannot put first and last, so I have only 3 carbon available. I can draw a branch with any one of them. So example, I draw a branch with this one. So this will be CH on the left hand side, the second carbon from left hand side. So this will have 3 hydrogen. This will have 2 hydrogen, 1 hydrogen. This will have 3 hydrogens, 2 hydrogen, 2 hydrogen,
2-methyl-hexane.
not hexane,
I
pentane.
mean, pentane. Yeah, pentane. Sorry, 2-methyl-pentane.
So select the longest carbon chain. Numbering should start from nearest branch. So 1, 2, 3, 4, 1, 2. So this one is 2-methyl. Pentane. Is it clear how to draw the isomer of alkane? So draw straight, then draw the branch. Um, how to do the first one in a straight chain? You mean the counting? Like example, because C4, okay, this one. Oh, I got your question now. Yeah, this will, if you change, like example, if you put CH3 and then you put CH2, then this is wrong. Why this is wrong? Because carbon maximum can form 4 bonds. So maximum bonds which a carbon can form are 4. So if you check here, the 2 of the bonds are already formed with other carbon. So left only 2 bonds, not 3 bonds. That's why there should be 2 hydrogen instead of 3 hydrogen. Is it clear? Your question was like, if the pattern changes, the hydrocarbon structure will not be accurate, because that's why if you check when I draw, I am not drawing hydrogen at all. I'm drawing hydrogen at the last. I want to draw 6 carbon atoms first. So I draw 6 carbon atoms. Then the first carbon atom, because of only one bond is there with hydrogen, one carbon, then remaining 3 hydrogen will be there. 2 bonds, so remaining 2 hydrogen. I cannot put 3. Why? Because carbon maximum can form. It is not necessary you try to memorize the pattern. You can just understand from a concept that carbon maximum can form 4 bonds. That's the number which carbon can form. So you don't have to memorize this. Just remember, if carbon can form 4 bonds, one of the bond is already formed. So how many hydrogen can adjust here? Only 3 hydrogen can adjust. That's why we write CH3. For the second carbon, 2 of the bonds are already formed. So how many hydrogen adjust? 2. For third, 2 are already formed, so 2 can adjust. For the fourth one, 2 are already formed, so 2 can adjust. And the last one is formed, so 3 can be adjusted. So it will be hexane. So this was about alkanes. Tomorrow we'll discuss alkene. There will be another session after a 10 minutes break in which I'll discuss the past paper with you. I'm ending the session now, and after 10 minutes, I'll share another link.